Hello students, we are starting with a new topic. We have completed lines. So now we are starting with planes. So as you knew, the name of the topic was lines and planes. Lines is over. Now we are starting with planes. So the first thing that we will do is we will define what is a plane. Very easy topic. If you have understood lines, then planes you will definitely find very easy. If you have the concepts of lines, the fundamentals of lines are clear, lines in 3D, then planes would definitely be easier for you. So let us define a plane. So a plane is a surface. A plane is a surface such that the line joining any two points on it lies entirely on it. So I give you some explanation for this. Suppose I have right now you see the screen. Okay, you see the screen, and on this screen, this is a surface, right? The screen is a surface. The screen is a surface. What is it? It is a surface. See, I'm moving the pen on the surface. So we can call this surface as a plane of screen. It is the plane of your screen. If you're watching it and if you're watching this on laptop, then it is the surface of screen of laptop. If you're watching it on a mobile phone, then it is the surface of screen of mobile phone. So what is it? It is nothing but a plane. See, you have a plane. Okay, now how have we defined it? See, a plane is a surface. A plane is a surface such that the line joining any 2 points on it. Now you do one thing, take any 2 points on the surface. Take any 2 points on this surface. I take 2 points on this surface. What I do is I join these 2 points with a straight line. Now I notice that all the points on this line, they entirely lie on the surface. What I had 2 points on the surface. I joined these 2 points with a straight line. Now this straight line AB, it has infinite points on it. But I notice that all the points which are on straight line, they all are lying on the surface. All the points on the straight line lie on the surface, and hence this becomes the plane. It becomes a plane. So the line joining any 2 points on the surface lies entirely on the surface. Okay, this line completely lies on the surface. Now see, on the other hand, let me draw a cylinder. So here I draw a cylinder. Okay, so I have a cylinder here. Now you know that the surface of a cylinder, the curved surface of a cylinder, okay, there are total 3 surfaces you have in the cylinder. You have total 3 surfaces in the cylinder. So the first one is lower circular surface. This, the lower circle, which is a flat surface. Remember that this is a flat surface. The lower circle, it is a flat surface. Okay. And if this is a solid cylinder, if this is a solid cylinder, then what will happen? Then the upper circle, which is again a flat, the upper circle, which is again a flat surface. Okay. If this is a solid cylinder, then it is not a hollow cylinder. If it is a hollow cylinder, then what? Then you will have it as hollow, so you can put something inside the cylinder. Okay. But if it is a solid cylinder, then what will happen? It will be packed from top and bottom. Now see, these two surfaces are flat surface. You see this? This is flat surface. This is also flat surface. But we have one surface which is a circular, which is a curved surface. See, this surface is curved surface. Which surface is curved surface? This surface. See here. So this is curved surface. You check this. It is curved surface. It is a curved surface. See, right now I am not, because it is, or I'm trying to show a 3D object. I'm trying to show a 3D object on 2D screen. You know, you will have to imagine what is it like. See, this is a curved surface. You understand? If I have 2 points, see, I take 2 points on this curved surface. So let me have 1 point here, and the other point I have is here. 1 point here and other point here. Let me have this point as P. I write this point as P, and this is point P, this is point Q. I join these 2 points with a straight line. I join these 2 points with a straight line. And it is needless to say what will happen. You know, students, what will happen. I will only be able to see this side and this side of the, see, what did I do? I took 2 points on the curved surface P and Q. I took 2 points on the curved surface P and Q. Then I joined those 2 points with the help of a straight line. And what I notice that the straight line passes through these 2 points on the surface, curved surface, does not lie on the curved surface. It goes within the cylinder. See, I cannot see the part of the straight line, much of the part of the straight line, because it is inside the cylinder. It is inside the cylinder. So what I understand, that this surface which you have, this curved surface, it is not a plane, because 2 points which I have on the surface, when I join with a straight line, the line does not lie on the surface. The line does not lie entirely on the surface. Okay. But suppose if I had 2 points here, and if I had joined these 2 points, what would have happened? If I had 2 points here, if I have 2 points here and I join these 2 points with the help of a straight line, then these 2 points would, this line would lie completely on the surface. Okay, you have a surface of paper on which you write. So if you take any 2 points on that paper and you join with a straight line, you notice that all the points of the straight line lie on that page. So that page becomes a plane. It is a plane. I give you one more example, and that example is of a sphere. Think of a sphere. Okay. So I'm showing sphere to you with the help of a circle. Okay, so as you know, students, a sphere is a curved figure. A sphere is a curved figure. Okay, so this is a sphere. What I do is I take 2 points on the sphere. I take 2 points on the sphere. Let this point be C, and here I have another point as D. What I do next, I join these 2 points with the help of a straight line. Now see, when I do that, what happens is, see, I will, when I do it, I will get the line as this. See, this is the way I will see the line. Okay. It is a sphere. It is like football that you use for playing soccer. So football, now you think of a football. On the surface of that football, the surface of a football, you take 1 point at one place, the other point on the surface somewhere else, and you join those 2 points. You join those 2 points with a straight line, with a straight line. So the straight line which you join, it will pierce through the football. It will pierce through the football, and your football, sorry to say, it will be punctured. Much part of the straight line lies inside the football. It is not lying on the surface. It is not lying on the surface. And remember, students, if you try to join these 2 points, if you try to join these 2 points on the surface, then you get something like this. It is no more a straight line. If you are joining it on the surface with the help of a pen, you will find that you get something like this, and this is not a straight line. Okay, you can't say, see, we are joining C and D and everything is lying on the surface. Though it is lying on the surface, it is no more a straight line. You can check, it becomes a curve. It becomes a curve. You need to join 2 points on the surface with the help of a straight line, and when you do so, what happens? The line which is joining these 2 points on the surface does not entirely lie on the surface, and hence the surface is not a plane. Only surfaces like the screen of a computer or laptop, of mobile phone, the surface like the surface of your blackboard on which your teachers write, the surface of whiteboard, then surface of your paper on which you all write. These surfaces are known as planes. These surfaces are known as planes. Why? Because any 2 points on the surface, any 2 points taken on the surface, if they are joined by straight lines, then the straight line entirely lie on that surface. I hope you have understood the definition of plane. Okay, so here now what you see, we are taking the discussion ahead. On the screen, you see three coordinate axes. Now, when do we have three coordinate axes? We have, we start our reference lines as these three coordinate axes when we want to study the things in 3D reference, that is 3D geometry. So here we want to study in space. Okay, we want to study something in space, not in plane. Okay, so if you want to have some study in only plane, that is XY plane, then what you do, you draw only X axis and Y axis. But whenever you see X, Y axis along with that Z axis, you should understand that here we want to study something in space. That is why we have X, Y, and Z axis. So here we have three mutually perpendicular axes, that is X axis and Y axis are perpendicular to each other. See, this X axis and Y axis, that gives you, they give you XY plane. Okay, XY plane. Then you have X axis and Z axis, they are also perpendicular. These two lines, that is x-axis and z-axis, when they are perpendicular, they define xz plane. It is xz plane. And when y-axis is y-axis and z-axis, they are perpendicular to each other. And these two mutually perpendicular axes, they define yz plane. Now here here I have written a plane can be determined by two intersecting lines. Now what best example it could be, what best example we can have than the intersecting coordinate axis. Now you notice x and y axis, they are intersecting. See, we are talking about two intersecting lines. Students, please be attentive. We are talking about two intersecting lines. Just now we had x and y axis intersecting each other. Look at the x axis and y axis. See, this is x axis and here you have y axis. These two axes are intersecting each other, and because they are intersecting each other, what you see is the plane, which is xy plane. Two lines, whenever two lines intersect, remember, whenever two lines intersect each other, they give us a plane. And see, that is xy plane. You see this? This is xy plane. This is xy plane. You see this? This is xy plane. This is xy plane. Okay, if I have to mark that xy plane, it would actually be this way. This is xy plane. I will not do the marking for full screen because I do not know whether it will actually be viewed by you the way I want it to be. See, this is xy plane. This is xy plane. It will have see, this is xy plane. This plane here is xy plane. This is XY plane. I hope now it is XY plane. Then you have the intersection of x-axis and z-axis. So that will give you the xz plane. It will be xz plane. See, the z-axis, the vertical z-axis, and this is x-axis. So this will give you xz plane. It will give you xz plane. I have made an attempt to show you xz plane. This is xz plane. And then you will have YZ plane. The YZ plane is this way. The YZ plane. This is YZ plane. The three planes are mutually perpendicular to each other. Anyways, so let me have only XZ plane on the screen. Okay, I remove all other planes. I have only XZ plane. Now what I do is in general, I draw any two lines. I draw any two lines in general, and see these two lines are intersecting each other. Now remember that these two intersecting lines, if I write this as L1 and L2, these two intersecting lines also they define a plane. Okay, you can imagine the plane that these two lines define. Okay, it would be plane this way. See, they define a plane here. They define a plane here. See, they define a plane here. The two intersecting lines, you can do this experiment. You can take two sticks, or you can take two pencils, and those two pencils, if they are intersecting each other, you will find that those two pencils make a plane. Okay, any two intersecting lines, you can take two sticks, those two intersecting sticks will also make a plane. So this is here a plane. Okay, further, a plane can also be determined by two parallel lines. See, if I have, so this is the way we can have a plane. When there are two lines intersecting, they define a plane. They determine a plane. We can have plane even by two parallel lines. Two parallel lines can also have, can also define a plane. And for that, see, what I will do is on the screen you see this xy plane, you see this xy plane. Now you can just check in xy plane, if I name this plane as plane ABCD, plane ABCD, you notice that line AB and line CD, they are parallel lines. Look at the lines AB and CD, they are parallel lines, and these two parallel lines, aren't they defining a plane? Yes, they are. Same way, line AD and BC, they are also parallel lines, and they are also defining a plane. Any two parallel lines, okay, what you can do is And see, this is all happening in 3D space, okay, three-dimensional space. What you can do is, you can, in both of your hands, you can hold two pencils. You can hold two pencils and just try to hold them parallel to each other, okay? Whatever orientation you want to give, whichever direction you want to give to pencils, it is okay. Just try to hold them parallel to each other. And then you will find that there is one imaginary plane which could be drawn through those two parallel pencils. The plane which will contain both the pencils. Okay, that is, two parallel lines can also define a plane. We can also have a plane, we can also define or determine a plane by a line. A plane can be determined by a line and a point outside it, and a point outside the line. What does that mean? Suppose I have a line here. Okay, I have a line here, and then I have a point here. So this line and this point, they define a plane. How? Very simple. I will start from the point and join any point on the line. Again here, I will start from the point and join any point on the line. And now what I see is a plane. Check, I got a plane. So remember, students, that how could a plane be determined? You can determine plane by two intersecting lines. You can determine plane by two parallel lines. You can also determine a plane by a line and a point outside the line, and a point outside the line. This is line L and this is point outside the line. We can also determine a plane by three non-collinear points. The last one is three non-collinear points. Three non-collinear points. If we have three non-collinear points, they will definitely define a plane. Okay. For that, what I will do is, let me have three non-collinear points here. So say I have a point P, I have a point Q, and then I have a point R. Now see, these 3 points, they define a plane. What they define? They define a plane. How? I'll show it to you. See. Join P with Q. Join Q with R, and join P with R, Q with R, and P with Q. See, these 3 points you join. And when you join these 3 points, what do you end up with? No credit for guessing, because you will end up with a plane. See, you end up with a plane. 3 points will definitely define a unique plane. You see this? You end up with this plane. You end up with this plane. I hope it's clear to you all. So these are the 4 different ways you can determine which will determine a plane, which will determine a unique plane. 2 intersecting lines will define a unique plane. Two parallel lines will define a unique plane. A line and a point outside the line will determine a unique plane, and three non-collinear points will also determine a unique plane. Okay, so taking the discussion ahead, I would like to mention here, students, that you remember when we did lines, when we studied lines in 3D, I had made a specific, very specific statement that if you want to define a unique line, then if you want to define a unique line, then you should have one point on the line and you should have a vector parallel to the line. Okay, so let's have a revision of this. For determining a unique line, okay, so say this is b bar, vector b bar. So here I write for a unique line, for a unique line, we must have, I'm sorry, we must have one point on the line, one point on the line, and a vector parallel to the line. For determining for determining a unique line, what are the minimum required things that we have? The minimum required things will be, we should have one point on the line and we must have a vector parallel to the line. Now see, so far as this parallel vector is concerned, it can be given in many ways. You know, they can give you the DRS of the line. You know, if the DRS of the line, see, a vector parallel to the line, this could even be replaced by DRS of the line. Okay, so they give us a DRS of line. It is one and the same thing, because if you have the DRS of line, with the help of DRS you can write the parallel vector to the line, or they can give you the DCS of line, because once again, if they give you the DCS of line, you can write a unit vector along the line. Once again, ultimately, why do we need this vector parallel to the line? Why do we need a parallel vector? Because that gives the direction to the line, that gives the that determines the orientation of the line. With the help of this vector only, I understand that in what direction the line is, and with the help of this point I understand that where the line is, where the line is. If I don't have this point, then if I don't have this point, I have only the direction, then I will only be able to draw lines parallel to B bar. I can have infinite lines parallel to B bar, but only when I have this point, I understand that line is passing through this point. So this is the line. So what do I need? I need one point on the line and the direction of the line. I need one point on the line and the direction of the line. If you remember, there was one more theory where we determined the line with the help of 2 points on the line. So see, when you have 2 points on the line, now 2 points, we do not need a vector parallel, because 2 points once again give you what? The direction to the line. So remember, for a line, what you need one point on the line and the vector parallel to the line, vector parallel to the line. Now we go to planes. Listen, students, to determine a plane, I have a plane here. So I have a plane here. Remember students, to determine a plane, a unique plane, what you need is one point on the plane. You need one point on the plane. Somewhere you need a point on the plane, and you need a vector perpendicular to the plane. You need a vector perpendicular to the plane. I repeat again, what we need to determine unique plane, to determine unique plane, you need one point on the plane, say the point is A, and you need a vector which is perpendicular to the plane. This vector which is perpendicular to the plane, we call this as a normal vector. It is a normal vector. Okay, we call this as n bar. It is normal vector. Say this is alpha plane. Okay, it's a unique plane. Now what you need to understand here is, I repeat again, let us go slow students. We are going slow, no doubt, but we have to study each and everything. See, to determine a unique plane, we must have one point on the plane, and a vector perpendicular to the plane. A vector perpendicular to the plane known as normal vector. Normal vector. Normal. Now see, suppose this plane, I call it as alpha plane. Okay, the unique plane which I'm talking about, suppose this is alpha plane. What is the name of this unique plane? It is alpha plane. Alpha. Now the problem here is, if I do not have any of these two given things, I may not be able to locate the alpha plane. See, this alpha plane is the unique plane. Try to understand. Think the alpha plane is the unique plane. So how could I locate the unique plane? Because I knew that alpha plane is passing through point A. It contains point A on it. From these infinite points, A is one of the point. It has infinite points, alpha plane, and A is one of the point. So since I knew that point, I knew that the alpha plane is passing through that point. Now suppose students, if I wasn't given this vector n bar, okay, I knew two things. Number one, that plane is passing through the plane is passing through point A, and number two, the plane is perpendicular to vector n bar. If any of these two is missing, I won't be able to get alpha plane. For example, suppose I am not given the point from where the plane is passing. If I'm not given the point from where the plane is passing, what would happen? Then I could be having infinite numbers of plane. I'm not given the point from where the plane is passing. I'm not given that. And just because I'm not given that, I can have infinite planes. Which are perpendicular to given vector, I can have infinite planes which are perpendicular to given vector. Try to understand this. I am not given the point. I am not given the point from where the plane is passing. I'm only given that plane is parallel to, sorry, the plane is perpendicular to n bar. I'm only given the perpendicular vector. Now, since I am given only the perpendicular vector, you can understand, students, there are infinite such planes which would be, you see this, even this plane is also, even this plane is also perpendicular to, it is also perpendicular to n bar. This is also perpendicular to n bar. See, this plane. See, what was I given? I am given that n bar is perpendicular to the plane. So what I notice, even this plane, n bar is perpendicular to infinite such parallel planes. You see this? N bar is perpendicular to even this plane. N bar is perpendicular to this plane as well. I can have infinite such parallel planes. This n bar, vector n bar, is perpendicular to all these parallel planes. There are infinite such planes. How would I determine my unique plane unless I'm given one point on the plane? I hope you understand. Unless you are given one point on the plane, you will not be able to determine the unique plane. So for determining the unique plane, for determining the unique plane, what do you need? You need one point on the plane and you need a vector perpendicular to the plane. For the line, what you remember what you had? For the line you had one point on the line and a vector parallel to the line. But for plane, what you need? You need one point on the plane and a vector perpendicular to the plane. Similarly, students, suppose now this time in the previous example, I said, in the previous illustration, I said that I'm given only the perpendicular vector. I'm not given the point. So what problem we faced? What difficulties we had, you understood. There are infinite planes to which this n bar is perpendicular. I'm not able to decide which unique plane. Similarly, if suppose I am given the point on the plane, I'm given a point on the plane, but I'm not given the normal vector. Again, I will not be able to determine the unique plane. If I'm given the plane is passing through this point A, that's it. Nothing more is given to me. I'm given that the plane is passing through this point A. See what would happen. See, I can have a plane here. I can have a plane which is containing this point A. Point A is contained even by this plane. I can have a plane here which is containing this plane, this point. This plane also contains point A. This point A is being contained even by this plane. So what was I given? I was given, you will have to imagine here because I'm finding it quite difficult, explaining on this 2D screen, the 3D concept. See, this point A also lies on the plane. Call this as beta plane. See, this is say beta plane. I can have infinite such planes, and those all planes may contain point A. So if you are given just one point and you are asked to draw plane which contain that point, there can be infinite such planes. So what I'm trying to tell you is, to define a unique plane, you need one point on the plane and you need a vector perpendicular to the plane. Okay. So let me once again say this. What did I say? I said to determine a unique plane, we must have one point on the plane. Now see how we will be given one point on the plane. To give one point on the plane, I might be given the coordinates of the plane, coordinates of the point. So that is, say I'm given x1, y1, z1. This is one way I can be given the point on the plane, or the another way of giving a point is I can also be given the position vector. I can also be given the position vector that is from the origin. So I can be given this vector a bar, and what will this a bar be? The a bar will be x1 I cap plus y1 j cap plus z1 k cap. This is another way of giving the point on the plane. Instead of giving the point coordinates, they give the position vector of the point. It is one and the same thing. Now, the another thing that we need, a vector perpendicular to the plane, known as normal vector, or simply the normal. Okay, it is simply known as the normal. The normal. What is meaning of the normal? The normal means a vector which is perpendicular to the plane. Now remember students, how we will be given a normal vector to the plane. They can give us directly the vector. Suppose they give me a1 I cap plus b1 j cap plus c1 k cap is a vector which is perpendicular to the required plane. This is one way we can be given the n bar, or they might simply give us a1 B1, A1, B1, C1, A1, B1, C1 are the DRS of the normal vector. They can give us the DRS of the normal vector. Now, once we are given the DRS of the normal vector, once again we can find the normal vector. Okay. One more very important thing here is, listen to this statement. There can be infinite vectors perpendicular to one plane. Okay. So just don't worry. Like, see, I have a normal vector here. I can have a vector here. See, this is also perpendicular because it is parallel. It is parallel to this vector. So every vector which is parallel to this normal vector will definitely be perpendicular to the plane. So for a plane, remember, for a plane, there can be infinite vectors perpendicular to it. I can have infinite vectors perpendicular to this plane. Just do not worry. We need only one such vector. We need just one normal vector. There can be infinite vectors perpendicular to the plane. See, they all are parallel to each other and they all are perpendicular. See, they all are perpendiculars. Let them be. We need only one. We need only one. I hope the idea is clear. Okay. So if I know the DRS of one of these, if I know the DRS of one of these normal vectors, you know the other normal vectors would have proportional DRS. They will have proportional DRS. Suppose A1, B1, C1 is the DRS of this. So DRS of this will be, DRS of this might be 2A1, 2B1, 2C1. DRS of this might be 3A1, 3B1, 3C1. DRS of this might be A1 by 2, B1 by 2, C1 by 2. So you just don't have to worry. Okay, there can be infinite normals to a plane. We need just one normal vector. So now we are going for equation of a plane. See, we will go for equation of plane passing through, equation of plane passing through a point and perpendicular to a vector and perpendicular to a vector. So this is the first theory of the topic plane. What is it? We are writing equation of a plane when it is passing through a point and it is perpendicular to a vector. Okay. As you know, these are the minimum required things for getting the equation of a plane. Or see, or the same statement could also have been written as or equation of plane when one point on the plane is given, one point on the plane is given and a perpendicular vector perpendicular to the plane is given. Okay, so please write the heading. So as per the heading, this is the plane. Here we are given one point on the plane and we are given a vector which is perpendicular to the plane. That is, this is the normal vector. I want to write the equation of this plane. See, what I would do, I will take a variable point on the plane. What I will do, I will take a variable point on the plane. So let R be a variable point on the plane. So here the theory starts. I write let A be a given point on the plane and n bar be the vector perpendicular to the plane. Let n bar be the vector perpendicular to the plane, that is, it is normal vector. I write let R be a variable point on the plane. So what will happen? Therefore, A bar, R bar are position vectors. They are the position vectors of points A and R with respect to the origin O. Got that? See, it is not required to draw it, but then in case if you want, you can go for it, no issue. but then as such, it is not required. I would suggest you not to draw these vectors, AR bar, OA bar and OR bar. It's okay if you don't draw it. Now what will happen is, see, I join the vector, I join the point A with R. And when I do that, I get vector AR bar. Now remember, this point A and point R, they are on the plane. They are on the plane. Point A is on the plane. It was given to us. I assumed the variable point are on the plane. Now what does that mean? It means if these 2 points are on the plane, the vector AR bar lies on the plane. If these 2 points are on the plane, the vector AR bar is entirely on the plane. Now, because AR bar is on the plane and N bar is perpendicular to the plane, then automatically AR bar is perpendicular to N bar. The vector AR bar and the vector N bar, they are having angle between them as 90°. They are having angle between them as 90°. I can show it to you. See here. This is AR bar. Okay. I'm shifting this AR bar in the plane. Okay. See. What is the angle now? Tell me. What is the angle? The angle is 90°. It is needless to say. The angle is 90°. So what I can say, I will write here that AR bar referring to adjacent figure. I will write here AR bar is perpendicular to N bar. Therefore AR bar dot N bar is 0. You know this? If 2 vectors are perpendicular to each other, their dot product is 0. So therefore you have R bar minus A bar dot N bar is 0. Now I will distribute dot over difference. Okay, we have done it so many times earlier. So see, I will get therefore R bar dot N bar minus A bar dot N bar is 0. So therefore R bar dot N bar equals to A bar dot N bar. And this is, see students, this is the required equation of plane. This is the required equation of plane, which is in vector form. This is vector equation. I write here, this is vector equation of plane in scalar product form. Okay, very simple students, very simple. What did we do? There was a given point. Yes. There was a given vector perpendicular. Yes. I took a variable point. Oh yes. AR bar is perpendicular to N bar. Yes. Then I applied the dot product, and the dot product is equal to 0 because the vectors are perpendicular to each other. How simple it is. Okay. So you will now copy this in your notebook. Okay, I missed a word here. We should have a point here. Okay, let A be a given point on the plane. After completing the vector equation, that is in scalar product form, now we are going to write the equation of this plane in Cartesian form. Now see, in order to write it in Cartesian form, we will first write the coordinates of the given point and the given vector. Okay, So for that, let me just assume here, I will write here, let the given point A be x1, y1, z1, and the given normal vector, which is perpendicular vector, given normal vector and the given normal vector n bar be say a1 I cap plus b1 j cap plus c1 k cap. As a matter of fact, they could have even said that DRS of n bar are a1 b1 c1. So instead of giving the normal vector completely the way I wrote, they could have given the DRS a1 b1 c1. That would also mean the same thing. So what I'm given the point A, and this is n bar. So this is something we are given. Remember, these two are given to us. Now I shall assume the variable vector. Let R, which is x comma y comma z, let R x comma y comma z be a variable point on the plane. Variable point on the plane. On the plane. Okay. So now we will right. Therefore, see from point A we can have A bar. What is A bar? A bar is x1 I cap plus y1 j cap plus z1 k cap. And what is R bar? R bar would be xi cap plus yj cap plus zk cap, because R is a variable point, so we take R bar, R as xyz, R as xyz. Now see, now what? I will substitute this all in equation 1. I write using A bar, R bar and N bar in equation 1. We get what we will get. You can check R bar dot N bar. So xi cap plus yj cap plus zk cap dot n bar. N bar is a1 I cap plus b1 j cap plus c1 k cap equals to a bar dot n bar, r bar dot n bar. Now a bar dot n bar. What is a bar? A bar is x1 I cap plus y1 j cap plus z1 k cap dot n bar. What is n bar? N bar is a1 I cap plus b1 j cap plus c1 k cap. Okay. Now see what this, you know how to take dot product when you are given two vectors like this. Okay. So dot product here will be, it will be a1x plus b1y plus c1z, right? So here you will get a1x, a1 into x plus b1 into y plus b1 into y plus c1 into z equals to, this side what you will get? You will get a1 x1 plus b1 y1 plus c1 z1. Okay. And remember students, this thing which you got, this is the Cartesian equation of the plane. In this equation, which is the Cartesian equation, see, x1, y1, z1 are the given coordinates. It means they are the given constant numbers. They are the fixed numbers. At the same time, this is given normal. A1, B1, C1 are the DRS of the normal. Those are also given fixed constants. Now what I'm trying to tell you is, since x1, y1, z1, a1, b1, c1, these are fixed given numbers, the right hand side of this equation will give us a single number. What will it give us? This will give us a single number. It will be a single number. Okay. So I write here, let, let, okay, first before that I will write, this is the equation of plane in Cartesian form, okay. This is 2. Now students, see, this is going to be a number. Just imagine if you had here 2 comma 3 comma minus 7, and here you had, say, I'm just writing any vectors, a minus 2i cap plus 3j cap plus 7k cap. What would have happened? 2 into minus 2 plus 3 into 3 plus minus 7 into 7. That would have given you simply a number. You understand? So similarly, this RHS, try understanding that this RHS which I have of equation number 2, that is equation number 2, the RHS which I have, this RHS is going to be a number. So for the sake of brevity, that is to make it small, to make it look small and clear and easy, see what I will write. I will write let a1x1 plus b1y1 plus c1z1 equals to negative d1. See, it is a number, just it is a number, and that number I am writing by negative d1. Okay, therefore we get what we will get. Therefore we get, you will get a1x plus b1y plus c1z equals to negative d1. That is a1x plus b1y plus c1z a1x plus b1y plus c1z. It is not z1. I am sorry, here I wrote by mistake z1 plus c1z is equal to, it is I'm sorry, plus c1z1, a1x plus b1y plus c1z plus d1 equal to 0. See, this is more fine, this is more fine, more brief. Okay, so what I will say, this is equation of a plane in Cartesian form. This is the equation of plane in Cartesian form. And remember, in such equation, the coefficients of, just look at this, how interesting. In this equation, the coefficients of x, y, and z, what are they? A1, B1, C1, and they are nothing but the DRS of the normal. They are the DRS of the normal. Okay. Please copy this and learn it. So now let us solve a problem on the concept that we just covered. So here I have a question which says, find the vector equation of the plane passing through. Find the vector equation of a plane passing through the point having position vector. See, this is the position vector of the point through which our plane is passing. Okay, this is position vector of the point through which the plane is passing, or in other words, you can say this is the point on the plane. This is the point on the plane whose position vector is given, and perpendicular to the vector. See, this is the vector to which our plane is perpendicular. So in short, Are we given the required minimum required things? Are we given one point on the plane? Yes. Are we given a vector perpendicular to the plane? Yes. So can we find the equation of the plane? Yes. Okay. So I will write here. See, as I had told you, instead of giving the coordinates of the point on the plane, they have given the position vector of the point on the plane. Okay, so it is as such easier, they have made it for us. So I will write here. See, first thing I do is I write let A be the point on the plane. A be the point on the plane. Therefore, this is the position vector of point A, and hence that is A bar. What is it? It's A bar. So I will write, therefore A bar is I cap plus J cap plus K cap. Got that? Next. Now I write let n bar be the vector perpendicular to the plane. Let n bar be the vector perpendicular to the plane. So therefore n bar equals to 4I cap plus 5J cap plus 6K cap. Okay. What is next? Very simple. You don't have to remember anything. Just draw a plane. Just draw a plane. Okay, so I draw a plane here. Okay, that's so fine. Now what? Draw the perpendicular vector to the plane. So I draw a perpendicular vector to the plane. This is n bar. Then what? Take a point on the plane. I take a point A on the plane. And what? Take a variable point R on the plane. Then what? Join point A with R. So you will get the vector AR bar. And this AR bar is definitely perpendicular to N bar, because AR bar lies completely on the plane. You got that? I will write here. Let point R, let point R be a variable point. Let point R be a variable point on the plane. Therefore, we can write. What you can write? You can write, okay, let point R in bracket write down R bar. So R bar is the position vector of point A. Okay. Therefore, we can write AR bar is perpendicular to N bar. Therefore, AR bar dot N bar is 0. AR bar dot N bar is 0. Therefore, you have R bar minus A bar dot N bar is equal to 0. Therefore, R bar dot N bar minus A bar dot N bar is 0. That is R bar dot N bar is equal to A bar dot N bar. I will substitute. So see, R bar we will keep as R bar. No need to write xi cap plus yj cap plus zk cap. No need to write it, because see, R bar is always going to be this only. A variable point, if you write the coordinates, it is always x comma y comma z. So R bar will always be xi cap plus yj cap plus zk cap. No need to write it. Okay. Yes, R bar dot N bar. What is N bar, my dear students? N bar is 4I cap plus 5J cap plus 6K cap. And here A bar dot N bar. A bar, you know, it is I cap plus J cap plus K cap. Dot N bar is 4I cap plus 5J cap plus 6K cap. Okay. So this gives you R bar dot 4I cap plus 5J cap plus 6K cap equals to 1 into 4, 4 plus 1 into 5, 5 plus 1 into 6, 6. So you will have final answer as right hand side will become 4 plus 6, 10 plus 5, 15. So the final answer is R bar dot. Okay, I will write on the next page. I will write this on the next page. Therefore, R bar dot 4I cap plus 5J cap plus 6K cap equals to 16. Sorry, it's not 16. I'm sorry, it's 15. Equals to 15. This is required vector equation of the plane. I hope you followed it. Read this, watch this whole thing again and solve it.